Hey guys, welcome you all to Machine Learning Day 1 Essential. And this is the day 5-day course in which you are going to learn basics about machine learning, and your trainer will be Shivam sir. So soon I'll be adding him, and guys, we are so sorry for the delay. Yep, so I'll not waste more of your time. So I'll add your trainer. Good evening, sir.
Good evening.
Yep. So sir, I'll be at the backend, so you can proceed.
Okay, thank you so much. Okay, guys. Hello, welcome you all. In this 5 day session, we are going to learn the basics of machine learning, and with a hands-on practice. Definitely, we are not going to. I am not going to take only the theoretical the concepts. Along with this theoretical concept, I am also going to take hands-on sessions also from today itself. Okay, so first, what is machine learning, and what is artificial intelligence? So it is nothing but it is just artificial intelligence is what we are trying to teach computers, which are which humans can already do, but we want to automate our system. We want to make we want to build smart machines, so which can make our life easier. Okay, so you already have a lot of examples revolving around you, like maybe a self-driving car, and there are a lot of things which you are using in your daily life, and definitely inside that particular a component, or inside that particular application, there is a part of a machine learning, or the whole machine learning is inside that. Okay, so if I talk about even a WhatsApp, so you are using a WhatsApp on a daily basis. So there is a function, auto completion, auto correction. So this auto completion and auto correction is a part of a machine learning. This can be developed only with the help of machine learning technique. Along with this, you are using a YouTube every day. Even our live streaming is going on a YouTube itself. So the YouTube recommendation system. Okay, so I think every one of you notice this thing, that whatever the videos, or whatever the maybe the concept which you are seeing more, so the same recommendation is kind of same kind of recommendation is make YouTube trying to make for you. Okay, so that is a kind of a recommendation system, and recommendation system is also a part of your artificial intelligence, your machine learning. Okay, so these are all the things, and even a lot of more things which people are using now. You can see nowadays around you, which capable enough to make your life easier, to build automation, build a kind of to make a kind to bring a kind of automation in your life. And all those things are possible with the help of a machine learning, with the help of a artificial intelligence. Now, what is this buzzword which we are going to discuss in upcoming 5 days? So, machine learning is nothing but it is a subset of artificial intelligence, and we actually trying to learn computers. We are trying to make computer learn and improve from the experience. Okay, so whatever the a recommendation, or whatever the auto correction, or whatever the auto completion things which is going on in a WhatsApp or in a YouTube, it's all happen because you are having some experience, you are having some past data. Okay, so and so machine learning works in a similar way. Okay, so any kind of a model which we are trying to build is based so that a particular model is able to make a prediction, it is able to make a decision based on past experiences, based on the past data. Okay, and based on the same data, we are trying to learn computers, and computers are trying to it automatically trying to learn a pattern from the data. Okay, so we are trying to generate a patterns, and that particular pattern is help us to make a decision or a prediction for the future data. Okay, so what are the things can be can happen in a future. Okay, so that is that we are able to predict, or that we are able to think because of this machine learning concept. Okay, so yeah, this whole idea is nothing, but the whole idea is about learning a pattern, and based on the pattern, learning a pattern from the experiences or the past data, you can say, and based on the pattern, we are trying to make decisions or predictions. And the most important thing, that a computer is able to learn these patterns directly from the past data, directly from the experience. We are not we are not, we don't need to program it explicitly. Okay, so we don't need to program it explicitly. It is our machine is capable enough. Okay, so we are trying to learn our machine in a way that it becomes capable enough to learn automatically from the experience, and and it automatically generates a prediction. It automatically help us to make a decision and prediction. Okay, we don't need to program it explicitly. Okay, so this is like a real scenario or real definition of a machine learning. Now there are like two kind of a task in machine learning which we usually see around us, like supervised learning and unsupervised learning. Okay, so there are like two kind of a task, or two kind of two types of a machine learning which usually people are trying to discuss. One is supervised, another one is unsupervised. So, and there is a like very minor difference in between these two kind of a task, or two different types of machine learning. Okay, so one in case of a supervised, what happened, you have a label data. Okay, so label data means if I give you a kind of a scenario that maybe you already know that what we need to predict. Okay, so like if I take a scenario that someone asks you the question, or maybe someone asks you to build a kind of a model, and that particular machine learning model is capable enough to predict maybe whether there is a rain tomorrow or not. Okay, so kind of you can say weather forecasting system. Okay, so we can try to predict whether there is a rain tomorrow or not. Okay, so yes or no, this kind of a prediction we can make based on the past history, based on the like experience, based on the past data. Maybe someone asks you as a machine learning engineer, someone asks you to make this prediction model, to make this machine learning model which is capable enough to take this decision for the future. Now this now in this particular for this particular prediction, for this to make this particular model, you have you have a data, you have a past data, and in that past data you along with the along with some independent variables. Okay, along with some independent variables. So independent variables means maybe what may be the possible factors of rain. Okay, so or what may be the possible factors that there is no rain. So maybe there is a factor like a temperature, or maybe a cloud, or maybe these kind of a factors which is responsible to for like a rain. So the factors are given, and along with these factors your output is also given. Okay, so whether with this factor, whether whether the rain happened or not. Okay, so along with the factors, the labels or the output is already is also given. So this is what called a supervised learning. That in case of supervised learning, we have a data, we have we have a input data, and along with the input data we also have a output data. Okay, maybe someone asks you to build a model which can predict whether the patient is having a cancer or not. Okay, so in this both the scenarios, we already know that what we need to predict. And for this we have both the things along with us. Okay, so we have a input data also, and along with this we have output data also. So this is what we call a supervised learning. Now in case of unsupervised learning, you don't have any label, you don't have any output, you just have a input data. Okay, so this is the difference, that in case of unsupervised learning you don't know that what exactly I need to predict. Okay, because you don't have a output data, you just have a input. Now based on this input, what we can try to make, So we can trying to discover some pattern. Okay, discover a pattern means we are trying to discover some like knowledge or the information which is hidden inside the input data itself, and then we can try to make a groups. Okay, so this kind of like unsupervised learning is mainly used in kind of market analysis. Okay, so suppose you are running some maybe some shop or maybe some website. So you always need to you always need to curious. Okay, so who are your good customer, who are your loyal customer, who are your fake customers, who are the maybe not a genuine customers. Okay, so maybe you are running some website, you are running some app. So there also you need to generalize this thing that who may be my loyal customers or maybe a loyal subscriber of my app. And then you need to decide who is my not maybe a loyal subscriber, or maybe you need to generalize that who may be a genuine subscriber. So this kind of a clustering, this is what we call a clustering or grouping. Okay, so this kind of a group you need to make. Okay, so based on some properties. Okay, so definitely loyal customer have some different properties than the customer who are like a fake customers have a different properties. Okay, so based on some properties, you need to find out these properties, and based on these properties you need to make this distinguishing. Okay, so if this property of person comes into the existence, so I can clarify. Okay, so this is my loyal customer, and then a different kind of a property supports the fake customers. Okay, so this is what we can do in case of unsupervised learning. Okay, so we don't have a label data, we don't have a output. We need to make some output, we need to label them. You can label them based on the a similar properties. Okay, so based on the similarity. So this is what happened in case of unsupervised learning. And definitely there are a lot of use cases which which is but you can think of like in each and every sector or in each and every field. People are using this concept machine learning. Okay, so even if it is a financial services. Okay, so like a stock market prediction, so people are using this concept even in a stock market, share market. Maybe you think of this like a name, you heard of this name, algorithmic trading. Okay, so people are doing algo trading nowadays to make a a big amount. Okay, in a share, from a share market, or from a even from a coins. Okay, so in a financial services, in a travel and hospitality, healthcare. So definitely in case of a healthcare, machine learning is playing a very huge role nowadays. Then a manufacturing, retailing, energy. So everywhere, each and every sector, people are using this concept, which is called a machine learning. Okay. Now, this is I just discussed this thing in a very short, that what is a machine learning and what may be the possible task which we can perform with a machine learning. Okay. Now, okay, so these are the ideas. These are the like a theory which we need to understand before starting, before start. Now, how we are able to make this? Okay, so suppose okay, so there is a problem of maybe a cancer detection, or there is a problem of making a recommendation system. So any kind of a problem which you are going to build, or any kind of a model which you are going to build, it definitely require a one programming language. And that programming language should be a very you can say a very easy and a very a simple to understand, so that anyone can program it. Okay, so mathematically we are able to understand, because there are definitely a lot of mathematics behind a machine learning in a back end. But to uh, to to solve this problem of to solve this real world problems, we need to program it, we need to make something. Okay, now how we are able to make these things? So we are able to make this thing, so with the help of some programming language. At least we need to have one programming language. Then only we are able to build this kind of a platform, or build this kind of a models. Now Python is that programming language which can help you, because I can definitely say that Python is a simplest programming language in terms of a complexity which is existing on this planet. Okay, so because even in a Python you can write your program in all the three ways. Okay, so you can write a program in form of a script, you can write a program in form of a, like in a functional way, you can write a program in form of a like a object oriented way. Okay, so uh, all these forms are supported by the Python. So these are the very first thing. And in terms of a machine learning, or in terms of a data science, deep learning, artificial intelligence, so what the main thing, or what is the like a main tool which make it a super special one, is the kind of a library or the packages which Python provides you. Okay, so inside a machine learning algorithm, so whenever we are trying to design a machine learning algorithm, or whenever we are trying to understand that how we are able to make this a future prediction, so definitely for making any future prediction we require a lot of mathematics. Okay, so this is possible only because of the kind of a mathematics which is going on in the back end. Okay, now to accomplish those mathematics, we are not able to write those mathematics in a plain in a scratch. Okay, because if you're trying to code those mathematics from a scratch, so it will take a lot of time, and it will like require a lot of computational power. It's also, and definitely your code becomes a more complex that even you not able to understand it. Okay, so to perform all these mathematics, to perform like, and even to visualize your things. Okay, so whatever the insights maybe which is my inside my data, to visualize those things, to get those insights out of the data, you need to have some libraries, you need to have some a kind of a package which can help you. So Python provides you that packages, Python provides you that libraries which can even perform a numerical computation, which can solve your mathematical problem. And along with solving that mathematical problem, it also helps you to make a visualizations. Okay, so this is a concept of like a Python which actually helps you to makes your machine learning model super easy to understand. Now these are like some packages which we are going to discuss just after the slide. Okay, so like these are some packages which actually helps you, like a NumPy. So NumPy is used for the numerical computation, whatever the uh, a kind of a mathematical calculation you have inside a machine learning, you can perform those mathematical computation, you can perform those scientific computation with the help of this library NumPy. Stands for numerical Python. Then the second one is a pandas. So pandas is used for a data manipulation and analysis. So although I'm going to take this into the hands-on, but in a simple way, you can understand like whatever the data you have. Real form of data is not like that you are able to understand that particular data in a very simple way. Okay, so maybe that data is present in a HTML format, or maybe a CSV format, or maybe any tabular format. Okay, so it's not easy to understand like those kind of data, even that is a structured data. But you are trying to manipulate your data in such a way, you are trying to keep your data in such a way that it's like become super easy to understand. And that is where pandas is going to help you to manipulate your data in that particular way. Then these are the three libraries which we can try to discuss for the visualization. Okay, so whatever the graphs or maybe the plots which actually helps you to understand that what is going on inside my data. And even it will help you your client, or the like maybe your company which where you are going to address this problem. So they are able to understand, okay, so fine, these are the things which is going on inside my data. Okay, so you need to use this like these are the libraries which actually helps you to make a kind of a visualization, to make a kind of a graph which help everyone. Okay, so now let me change the screen, and I will show you that I am going to start from a NumPy. Okay, and I will show you some like basic concepts or the functionalities of the NumPy, which actually helps you. to perform some numerical computations. Okay, so let me change my screen. One second. Okay, where is my? It is on the same screen, I hope. Yeah. Okay, so one second. Okay, fine. So now I am going to discuss about NumPy. Okay. So like to use any like a library of a Python, you need to import it first, because all these libraries which I'm going to take for a Python, for a machine learning, so that is not a part of a basic Python, or like you can say a core Python. Okay, so I need to import this. I need to import all these libraries. Okay, so I can import it directly, import NumPy, and then I can provide some alias name, so that I'm not we need not to use a NumPy again and again. We can like short this name as NP. Okay, so let me check whether there is some question. What is supervised learning? I think I take this part, that what is supervised learning. Uh, okay, where there is a label and you already know that what you need to predict, that is what we call a supervised learning. Stock exchange, I'm not able to understand why it mentioned. Can I get that PPT? Most probably yes. To detect and generalize unsupervised learning, then insurance premium. Can you post the PowerPoint file? Okay, I think Python best for MLA. Okay, now in a NumPy, what exactly this NumPy is able to solve is whenever you have a multi-dimensional array, or whenever you have a data in form of an array. So a core Python basic mathematics, which is inside a core Python, is not able to help you to perform those numerical computation. Okay, but NumPy can solve that problem. Okay, so whenever you have a multi-dimensional array, whenever you have a data in form of a array or maybe a matrices, so NumPy can help you to solve your problem. Okay, or to perform any kind of a mathematics. Okay, so I can create a one array with the NumPy. So np dot array, and in this way I can create my array. Okay, so this is nothing but okay, so this is my array, and now I can see this. So this is my array 2, 5, 7, and 2. These are the numbers which is inside my array. And even if I try to check the type of my a, so this is nothing but a numpy.nd array. So nd array stands for n dimensional array. Now so for this particular a is nothing but this is of one dimensional. Okay, so the dimension of this particular array is nothing but one. But yeah, it can be multi, it can be of any dimension. It can be 1, 2, 3, 4. It can be of any dimension. Okay, and even you can check this like a dimension with the help of this function and big. Okay, so the dimension of this particular array is nothing but 1. Now we can create a two-dimensional, three-dimensional array also. Okay, so maybe I can try to create in this way, np dot array, and inside this you can try to create a multi-dimensional array. So a 3, 5, 7, and 9. Now this is a two-dimensional array. Okay, so if you're trying to check b and then this is nothing but a two-dimensional array. Okay. So in a similar way, you can create maybe a three-dimension, four-dimensional array, and even you can increase the size also. Okay, even you can increase the shape also. Okay, so you can try to write a b dot shape. So this is nothing but 2 cross 4. So 2 cross 4 means what? A 2 row and 4 columns. Okay, so this particular array is having 2 rows and 4 columns. Fine. Now there is now I can take a very important concept which is inside this like a NumPy. Even this is a concept which is inside a Python also, and this is like a concept which people may ask in an interview. Okay, so the concept of a shallow copy and a deep copy. Okay, so suppose if I try to create an array, if I try to create maybe a different array. Okay, so I can take maybe x, and inside this x I can try to create np dot array, and then I can pass a numbers, maybe 2, 5, 6, and 8. Okay, so this is like a single dimension array. I create with np dot array. Now, suppose what I can try to do is I can try to take maybe another array y, and inside this y I can try to copy the element of array, the element which is inside array x in a, and with in a new array, in a new variable y. Okay, with a y equals to x. Now this method, or this way of copying the element, this way of copying the element is called a shallow copy. Okay, or shallow copy. Okay, so this method is called a shallow copy. Now if I try to run this y, so I'm able to get the same element over here. Okay, so inside x I'm having 2, 5, 6, 8, and 12, and now inside y, uh, again I'm having a same element. Fine. Now suppose if I make some modification. Okay, modification means if I change maybe any of this element. Okay, so in place of 6, okay, so maybe in place of 6 if I make it a 7. Okay, so in index value of 6 is nothing but 2, and in place of 6 maybe if I try to make it 7. Okay, now it is possible, and we are able to see the change. Okay, so in place of 6 we are able to get a 7 over here. Now if you run x, okay, although you didn't make the same change inside a x, but if you run x now, so the same change you are able to see in the x also. Okay, so whatever the change you make in a y, the same change is reflected in a x also. Okay, so this is what happened when you are trying to you are trying to copy like array in this way. This is called a shallow copy. Now if I try to make again, if I try to make a copy, but this time if I try to make a different type of copying, different kind of approach, if I try to follow a different kind of approach, and that is what we call a deep copy. Okay, so np dot copy, and I'm trying to copy the element of x itself. Okay, now this is called a deep copy. Okay, so now I'm having this element over here, 2, 5, 7, 8, and 12. Fine. Okay, so now the same element, the whatever the element we are having in x, the same element is reflected in z also. Now suppose if I do the same thing. Okay, so if I make some change in a z. Okay, so maybe in place of 7, if I try to make it 70. Okay, so now if I run this, so my z is changed. Okay, my z is changed, but if I run x, so x is remain same. Okay, so this is what happened in case of a deep copy. Okay, so in case of a shallow copy, whatever the change you make in a secondary array, the same change will reflect in the primary array also. But in case of a deep copy, the change you make in a secondary array is not going to reflect in a primary array. Okay, and this happened because when you're trying to make a copy in this particular way, so the element, along with the element, this particular thing happen in a same address. Okay, at a same at the same place. Okay, so this is why the address of this y is whatever the address of this x is become the address of this y also. Okay, so if the address is same, so whatever the change you are going to make in one array, definitely the change is going to reflect in the secondary array also. But now when you copy in this way, so in this way of copying, we are not trying to copy the address. Okay, so the address is different. Okay, so the address of x is different from the address of z. and that is why when you're trying to do like change in z, so the change is not going to reflect in x. Okay, so this is like a difference between a deep copy and shallow copy. Now, if I talk about another function, another important function of a NumPy, okay, so a range and a lean space. Okay, so these are the like two very important and very interesting function which is inside a NumPy. Okay, so now the range function is similar with the range function. Okay, so inside a core Python, you have one range function. Okay, so what range function did? Suppose a range function means it simply gives you the kind of a range. Okay, so suppose if you give like inside a range function, if you give two elements, maybe a 1 and 10. Okay, so what happened? You are able to get the element, you are able to get the all the element in between 1 to 10. Okay, means from 1 to 9, 1 2 3 4 5 6 7 8 9. Okay, so in this way you are able to get all the elements in between 1 to 10. Okay, by using this by using this range function. Okay, and now but the range function is part of a core Python. The same thing happen in a range function, but there is a slight difference. Okay, there is a slight difference in between these two. Okay, now let me check that. Let me take that difference. Okay, so suppose if I'm trying to make a range. Okay, and suppose I'm trying to take an element from 2. Like you need to give three things over here, or maybe you are able to give two things over here. Okay, so the starting value, that what is the initial value from where you want to start. Okay, so this is the initial value 2. Then you need to give the last value. Okay, so maybe the last value is 21 which you want to give. Okay, and then you need to provide the step size. Okay, although if you didn't provide the step size, so automatically it takes the step size as 1. Okay, but you can mention the step size, so you can mention the step size as maybe a 2 3 4 anything. So suppose I can take a step size as 3. Now if I run this, okay, so I am getting an answer over here 2 5. So my step size is 3 and I am getting a value in between 2 to 21. Okay, now if I take a range function. Okay, so if I take a range function, I think just one. Now the same thing will happen over here. So 2 and 21, and this is maybe the step size. Okay, so again I am getting the same element. Now let's check the difference. Okay, now what is the difference? So suppose if I change this step size from 3 to 2.5. Okay, so if I make this if I change the difference from 3 to 2.5, now it will give you an error because this range function. Okay, so this the range function of core Python is not able to take a floating point number. Okay, but this range function of NumPy is able to take this floating point number. Okay, so even you can try to give the floating point integer also, and it can take a range of it can take a step size of floating point number. Okay, so this is the difference, and the concept is same. The concept of range function and range function is similar. That uh, you need to give the initial value, you need to give the last value, and you are able to get all the values in between these two. Okay, the initial value and the last value. Okay, so this is what happened in case of a range function and a range function. Okay, let me check if there is some query. Okay, okay, so people are talking about, I think, the attendance sheet. Fine. Now the second function of this a NumPy is nothing but a lean space. Okay. Now what happened in case of a lean space? So in case of a lean space, what you can try to do is you can try to provide np dot lean space, and how it will this lean space function is able to generate the result. Okay, so maybe we can start from 2, we can go till a 20. Okay, and I can simply run this. Okay, even okay. So this 5 is not a step size. Okay, so this time this 5 is not a step size. In case of a lean space, what happened, you give the initial value that okay, so from here I want to start, then you give the end value, okay, so I want to go till this value, and then you need to give the step, you need to give like this the end value, rat step. Okay, so rat step means you need to give you need to give the size that this many number I want in between these two numbers. Okay, so in between 2 to 21, include 2 to 20, including 2 to 20, it's also I want to generate a five numbers. Okay, so this is a concept of lean space that you need to this five is nothing but how many numbers I want to generate in between 2 to 20. Okay, so I want to generate five numbers. If you remove this five, if you remove this five from here, so there is a like one thing, there is one function called num. Okay, so num is equals to 50. So by default, I think I just run this thing little bit earlier. So by default, it is going to generate a 50 numbers in between a 2 to 20. Okay, and definitely you can try to change this thing. Okay, so you can try to change this number. Okay, so now I'm trying to take, and I'm trying to take just five numbers in between 2 to 20. Okay, even you can try to make this maybe a 50. Okay, so now what happened, it will try to generate 15 numbers in between 2 to 20. Okay, and this rat step means this rat step is nothing but it is going to show you that what is the size it takes. Okay, because it trying to generate a numbers with and making a equal in a equal division. Okay, so the rat step is nothing but 1.28. Okay, so 2 plus 1.28 is nothing but 3.28. Then 3.28 plus 1.28 is nothing but 4.57. Okay, so this is a way it is able to generate a 15 numbers in between 2 to 20. Okay, so this is what happened in case of a red step. Fine. Now if I talk about if I talk about maybe some more like common arrays. Okay, so there are like some common arrays which we can try to build in case of a with the help of a numpy. Okay, so what kind of arrays which we can build? Okay, so these are like some very basic arrays. Okay, some very basic arrays which we can try to build. Okay, so now inside this Z, what I can try to do is I can try to write np dot zeros. Okay, so this zeros indicates what? This zeros is able to like indicate is nothing but we are trying to generate an array of size of maybe some size. Okay, so you can try to provide a size over here. So we are trying to generate a array of some size, maybe a 3 cross 3. Okay, and then and this array is nothing but it contains a zero only. Okay, so we are trying to generate an array where all the elements are zero and of maybe some size. Okay, so it may be a 3 cross 3, it may be a 4 cross 4, it may be a 3 cross 4, it may be a 4 cross 5, any number. Okay, similarly you can try to generate a array with maybe where all the elements are 1. You can generate a array where all the elements, where you just have a diagonal elements on a diagonal. Okay, rest of the elements are 0. So this kind of elements, this kind of array you can generate by using this by using numpy. Okay, so for generating a 1, you can try to write np dot ones. Okay, so this should be 4 cross 4, then it will be okay. Similarly, you can generate a diagonal element, not a diagonal, that is called, I think, identical matrix. Okay, identical matrix is a matrix where we have like a 1 on the diagonal and rest of the element is 0. Okay, so this kind of a generation you can do, this kind of you can generate this number. Okay. Now, one more thing, one like a very important concept which we can try to discuss over here, that we can also generate a random numbers. Okay, so with the help of NumPy, we can also generate a random numbers, and this is a very important concept because maybe sometimes anyone can ask you to build some kind of a like a scenario or to do some kind of a mathematics by generating the random numbers. Okay, so there are like three ways through which we can generate a random numbers in a NumPy. So I can try to write a random number generation. Okay. So here, what how I can write it? So the first way of generating the random numbers is nothing but np dot random dot rand. Okay, and then inside this you can try to provide a shape. Okay, so these are like random numbers which we are able to generate. Now, if you're trying to change it, so if you're trying to run it again, so you are able to see the numbers are changing again and again. Similarly, you can try to generate the random numbers in this way also. Okay, I will show you. np.random.random. Okay, now, so there is a difference between the numbers which you are generated with the help of np.random.rand and the numbers which you are generated with the help of np.random.randn. Okay, so the first function is able to generate a random numbers from a uniform distribution. Okay, so there are different kind of a probability distributions which are existed. Okay, so a uniform distribution is one of them, and the second in the second way, in the second function np.random.randn, so these numbers are generated from a standard normal distribution. Okay, now these are the like some a very basic and a very important concept which is available inside statistics and probability. And definitely in a future. Okay, so if you are going to join our like a pgp program, which is of like a 6 months course where we are going to learn from a very scratch, and then we are going to discuss we are going to make like a very projects on a real life data from the real world scenario. So from scratch to like you can say from scratch to expert level things we are going to do in that pgp program. So even you can try to join it. Okay, you can try to join that program. And the best part of our pgp program is this is that so if you join any of our program, okay, so maybe if you join this ml program, so you are able to get the access of all the other program. Okay, so we have a different program like web development, then python, django. So these are like different programs we are having, so you are able to get the access for all these different programs along with this if you are able to join this PGP data science and machine learning program. Okay, and I think there is some coupon also, and the coupon code is nothing but my name, Shivam. Okay, so that coupon is having a 4,000 discount. Okay, so even you can try to grab it. Okay, and definitely because yeah, in a very short term, in a very in this like maybe a 30-minute session, we are not able to discuss. It's not possible for us. It's not possible for us to discuss this kind of a concept like statistics and probabilities and all. Okay, so fine guys, but yeah, you can take this thing into account that these two numbers are come from a different distributions. Okay, and these distributions are nothing but a probability distributions. Okay, so one this particular thing, this particular numbers are come from the uniform distribution, and this particular number are come from the standard normal distribution. Okay, now and you can see the difference. Okay, so in a first like a case, you are able to see that all the numbers are in between 0 to 1, and in the second case all the numbers are they are having some minus number, negative numbers also. Okay, because if you're trying to, okay, so if you have a very like a short idea of a mean or maybe this kind of a statistics, okay, mean, standard deviation. Okay, so if you're trying to do the mean of this data, so the mean of this data is nothing but 0, and the standard deviation of this data is nothing but a 1. Okay. Now, if I no, but fine, you are able to generate a decimal numbers. Okay, even though these are the random numbers, but you are able to generate the random decimal numbers. Now, if I want to generate only random integer numbers, then how I can generate it? So for that, what you can try to do is you can try to write np dot random dot randint. Okay, and in this scenario, what you need to give is you need to give like a range 1 to 25. So this is the range. So I want to generate a number in between 1 to 25. And then here, what I can trying to do is I can try to give the shape. Okay, so maybe the shape of my array is nothing but 4 cross 5. Right? So I'm able to generate the integer random numbers in between 1 to 25, and I also give the shape, and the shape is nothing but 4 cross 5. Okay, now let me check whether there is some query or something. Attendance link is not working. Okay, people are more worried about the attendance link. Let's upgrade team bits. Okay, please take a look of this issue. Okay, now if I talk about maybe some more functionality of NumPy, so there is one very important, another important function which is available, that is what we call a masking. Okay, and even though we can also call it as a Boolean masking. Okay, so what is the meaning of this a masking and a Boolean masking? Okay, so now if I can show you this particular Boolean masking thing. Okay, so I already have a data, so we are not we are not we need not to like generate the random number again. We already have a data. So what I can try to do is I can trying to like initialize like I can try to take only those numbers which are maybe greater than 12. Okay, so in this matrix we have a number such as like 17, 22, 19, 15, then 4, 7, 21. Okay, so I just want to mask those element which is greater than 12. Okay, now if I run this, so I'm getting a value in case of true and false. Okay, so this is what we call the Boolean masking, because we are able these are the Boolean numbers, true and false. Okay, and where there is a like a number greater than 12, we are getting a true over there, and where there is a number lesser than 12, we are getting a false over there. Okay, so this is what happened in case of a Boolean masking. And even though suppose if you want to mask only those data which are greater than 12, so what you can trying to do, you can try to make this thing possible in this particular way. Okay, so now I am getting only those data, I am getting only those like a information where my data is my value is greater than 12. Okay, so this is what happened in case of a Boolean masking. Now, if I talk about another function, okay, so let me check. Okay, and one more thing. So I need to ask in a team, Subrat and anyone who is there. So can we continue, or we will continue from tomorrow because it's 9:04. So can we continue till 9:15 or something, or we need to wrap up? Okay. Okay, so I think we can continue because we start a little bit late. So I can take one more important like scenario of this NumPy. So, what kind of a mathematics, what kind of mathematical operation or arithmetic operation we can solve by using this NumPy library? Okay, so that I can take into the consideration. So for that, maybe I can try to create one like a two array. So I can try to create an array with like np dot array. Okay, and here I can provide maybe an elements. Okay, so one, two, and then I can try to provide maybe more numbers here also. So np dot array. Okay, so I'm having should be into a double braces, otherwise it will show you an error. Okay, fine. So I'm having two array x and y. Now, if I want to perform some arithmetic operations, so arithmetic operations are like what we can perform addition, or we can perform like a subtraction, multiplication, division. So any kind of arithmetic operation is possible. So the direct operation is possible. Even we can try to perform this operation with the help of numpy. Okay, because this is a numpy array, so even the direct operation is possible. So we can try to directly combine it, x plus y. Okay, so x plus y becomes what? We are able to make this element wise addition. Okay, so 1 plus 5, then a 2 plus 6, then 3 plus 3, and then 4 plus 9. Similarly, we can try to perform like x minus y. This is also possible. And even with the help of a function also it is possible. Okay, so I can try to write np dot add, and then I can pass my like two array x and y. Okay, and similarly np dot subtract is possible. Okay, so addition and subtraction is happen in a similar way, in a similar fashion. And but like in case of even np dot divide is also possible, and this is also happen in a similar like a fashion. Okay, so these three things are completely fine with the with the numpy. But suppose if I trying to like multiply it. Okay, so maybe if I trying to multiply it with a like np dot multiply, and maybe if I'm trying to multiply it in a in a similar way. Okay, so I need to run this x and y over here. Then only you are able to get this concept. So this is my x, and then this is my y. And when you are trying to multiply it, okay, so just trying to just trying to check this result. Okay, so in both the way I'm getting the equal numbers 5, 12, 9, and 36. But this multiplication is not a matrix multiplication. Okay, so if you are trying to check, so this particular multiplication which we are going to which we are able to get over here, so this particular multiplication is not a matrix multiplication. This is actually a element wise multiplication. Okay, so we are getting 1 cross 5. So 1 cross 5 is nothing but 5. 2 cross 6 is 12. 3 cross 3 is 9. 9 4 cross 9 is 36. Okay, so this is a element wise multiplication. This is not this is element wise multiplication. This is not a matrix multiplication which we actually want to do. So this is a problem with this with this multiply operation, or whenever we are trying to multiply it in a in a very in a very short way. Now, to perform a matrix multiplication, okay, so to perform a proper matrix multiplication, what you need to do is you can try to perform that thing in this way: x at the rate y. Okay, so now if you have an idea, okay, so if you know that how we can try to perform a matrix multiplication, because we already learned this kind of a mathematics in our childhood. Okay, so if you know this concept that so I think this is a way of making a matrix multiplication: 1 2, and then 5 3, then 1 2 6 9, 3 4 5 3 3 4 6 9. Okay, so if you are able to do this calculation, so definitely you are able to get these numbers. Okay, so this is what happened. This is a matrix multiplication, and another way of doing this matrix multiplication is nothing but np dot dot. You are getting the same result. Okay, so these two methods are like these two function you can use to perform a proper matrix multiplication, because we need to apply this instead of like that. Okay, so find these things are possible. Even you can try to find out the log of any value. You can try to find out the square root of any value. Anything is possible with the help of NumPy. Okay, so you can try to find out the square root of any array. Fine. You can try to find out the log, np.log. Okay, so anything is possible with this like NumPy. Fine. Now, one more very important and very you can say a very yeah, very important concept and very a key concept in with the NumPy, which we can try to perform, is nothing but a broadcasting. Okay, so we can perform a broadcasting operation. We can try to broadcast any array or any number on a like array with the help of a NumPy broadcasting. Okay, so how we can perform this broadcasting? Okay, so we can try to broadcast in this way that suppose we have this array np dot zeros. Then we have this number s is equals to s plus. Okay, so okay, so this is my array where all the elements are 0. Now, what I can try to do is I can try to write s plus maybe 100 over here. Okay, so what I'm trying to do over here, I'm trying to broadcast this 100 on each and every element of this s. Okay, so s is my array, and I can try to broadcast 100 on every number on every element of this particular array. Okay, now if I run this, so yes, I'm able to broadcast it. Okay, so you are able to get 100 at every place. Fine. So this is what we call a broadcasting. Even if you're trying to store it somewhere, okay, so suppose if you're trying to store it somewhere, so in that new array you are able to get this number, okay, every time. Because this time if you again run this s, so you are getting you are again getting 0. Okay, because you didn't store this value somewhere. Okay, now, so fine, and in a similar way, you can perform a row broadcasting, and even you can perform the column broadcasting. Okay, so you can try to add a row wise, and even you can try to add column wise. Okay, both the ways are possible. Now, if I want to add a row wise, so maybe if I try to write arrows, so in a row wise, I need to give a 4 elements which I want to broadcast. So np dot array, and then I can give my 4 elements 4, 5, 6, and 7. Okay, so this is my arrows. So now I want to broadcast this particular element 4, 5, 6, and 7 on my array s. Okay, so yes, I can broadcast it. There is no issue. Okay, so I can try to write x, and I can try to write s plus arrows. Okay, and then if I run this, so you are so this is what happened. This is a nothing but a this is row broadcasting. Okay, we are able to we are able to we are able to get this 4, 5, 6, 7 in this fashion. So 4, 5, 6, 7, then again 4, 5, 6, 7, again 4, 5, 6, 7, again 4, 5, 6, 7. Okay, so this is what we call a row broadcasting. Suppose you want to do the column broadcasting. Column broadcasting means in this fashion, in a vertical fashion. Okay, here we are able to do this broadcasting in a horizontal fashion. Suppose if you want to make this broadcasting in a vertical fashion. So for a vertical fashion, what you need to do is, and now there is a column broadcasting which you can do. So np dot array, and then suppose you have like some numbers over here 2, 7, 8, and 9. Okay. Now, if I want to broadcast in this fashion, okay, so in a vertical fashion, so I want to transpose, I need to transpose it, because this is not like I am not able to broadcast because these are the numbers. These numbers are arranged in a horizontal fashion. Okay, so I need to change it. I need to make it in a I need to transpose it. Okay, so how I am able to transpose it? So to transpose it, uh, there is a simple operation available inside a numpy, which is dot t. Okay, so now these things are transposed. Okay, so I can store this value inside this, and I can try to run the same code which I run in the above cell. Okay, so a calls. Now if I run this, so yes, this is a column broadcasting. Okay, so 2789 2789 2789 2789. Okay, so this is what we call the column broadcasting. Okay, so even we can try to broadcast any element or maybe a set of elements in a row wise manner, or we can try to broadcast like a set of elements in a column wise manner, horizontal way in a and a vertical way. Both things are possible with the help of this broadcasting operation. Okay, so I think, guys, this is enough for today. We are able to understand a lot of concepts and maybe functions of NumPy today itself. Now we okay, so maybe there are like some more, or yeah, not like some more. There are like a lot of operations or a lot of functions which are like available inside a NumPy, but definitely we don't have like that much amount of time to discuss all. But I'm trying to discuss like some more basic and essential concept which may be of regular use kind of a concept, and then we are trying to we are going to proceed with the pandas. Okay, now if you have any query, so yeah, you can ask that particular query. Okay, so anyone having any query or any questions, I'm happy to answer it. Okay, so who's there in the Subrat or anyway? So Subrat, I think that there is like no one is having any query or anything, so we can wrap up this session for today.